here. It says Carla and Tom plan to send their son to university. To pay for this, they will contribute 9 equal yearly payments to an account bearing interest at the APR of 8% compounded annually. 5 years after their last contribution, they will begin the first of 5 yearly withdrawals of $53,300 to pay for the university bills. How large must their yearly contributions be? So I like to think of this as a timeline. The beginning, they have $0. They save for 9 years. We don't know how much per year they're saving, but they're earning 8%. Then it's going to sit in the account for 5 years with no contributions, but it'll still be earning 8%. And then after that, this is the withdrawal period. We don't know how much it'll be at that point, but the withdrawal period is $53,300. And after the end of the 5 years withdrawal, it'll be back down to $0. So even though time starts at the left here and moves on its way to the right, we actually want to start this problem at the right and move our way to the left, because the right is where we have the most information. We know the most information about this time period over here, this 5-year block. We know the yearly withdrawals of $5,300. We know we're earning 8%. We know we start with, we are withdrawing them yearly, and it's also compounding yearly. So because this account, if we're thinking of this 5-year period here, is going to be going down in value, we'll be making withdrawals, then we're going to use this formula here with the negative exponent. So I've done this down here, and you kind of try not to pay attention to anything to the left too much right now. Just look at this part. So we started with, we're taking W as our withdrawals, 53,300, interest rate at 0.08, K is 1, and then T, time is 5 years. And we do this and we solve for P because that'll tell us the amount in the account needed to be able to do $53,300 withdrawals for 5 years. So if you solve that for P, type it in your calculator correctly, we get that the P amount, so 2012, 811. That's how much needs to be, oops, you want to erase this in this period of time here. Not eraser. It's not working. Okay. So at this point in time right here, we need, this is messing up a little bit, but we need the 212,800. 212,800 needs to be in the account at the beginning of this 5-year span. That's what we just found. 2012,800. So then we work backwards again. How much would need to be in the account before this 5-year span here? And this 5-year span, remember, we're not making any contributions. So there's no monthly contributions in this 5-year span, but we are continually earning 8% on that. So we're going to use this formula here, which is the compounding interest formula that we use when there's no monthly contributions or yearly, no continuing contributions, is this formula here. So I'm going to use this formula, and I put the 212, 811 that I just got from the last step, 811 here. I got from the last step, and I put that in the A spot. My interest rate's the same, 0.08. My time period's 5 because this is a 5-year span. And I solve for P in this case. So P is what I solve for here. As I do that, I get 144,835. So that's what I need right here is 144,835. That's the amount of money I need at the beginning of this time span here. Now, I'm working backwards again. How much am I going to need to deposit per year? That's the final question. How much do I deposit per year to be able to get this for 144,838 by the end of that 9-year span? So now this is a savings account that is going to be increasing in value where we're making yearly contributions. So we're going to use this formula here. And so this is the big long formula with the positive exponent because it's going up in value in this 9-year span. So as I go to this side, I put the 144,000 that I just got from the last step over here in the A spot because this time I'm trying to solve for D. I want to know what D is. So as I solve for D, I'd have to, a few little steps there to get the D alone. Finally, I find what my deposits need to be. My yearly deposits need to be $11,598.42, and I'll do that for 9 years. And doing that for 9 years, letting it sit for another 5, and withdrawing $53,300 a year allows me to pull that much out for the 5 years. So we worked our way backwards, and our final answer after it all was that $598.